Work is on finding proportional relationships using graphs. So at the very top, Isabel walks to work each morning. It takes her 5 minutes to travel one city block. So that's pretty important. 5 minutes to travel one city block. Use the information to complete parts A and B. Sketch a graph to show the number of blocks Isabel can travel in a specific amount of time. So obviously, if one block takes her 5 minutes, then 2 blocks would take her 10 minutes, 3 blocks would take her 15 minutes, so on and so forth. We can go ahead and even finish it up with 10 blocks would take her 50 minutes. Make sure that when you're drawing these graphs, you get a few points, and then that you do use a ruler to connect them. Graphs of proportional relationships also go through the origin, the point 0, 0, which makes sense, right? If she were to walk 0 city blocks, it would take her 0 minutes, or if she walked for 0 minutes, she would go 0 city blocks. So this, in part B, we're actually going to do basically all of that information is going to be right down here. So when we have the graph of a proportional relationship, the line always passes through the origin, which is, of course, the point 0, 0. The rate of change will be equal to the constant of proportionality. So we've already talked about rate of change on one of our other sheets. We've already talked about constant proportionality, so we're just saying obviously that those two things are equal. And the equation of the line will be the equation for a proportional relationship, y equals kx, remembering that k equals y divided by x. So how do we find the k when we only have a graph? Maybe we don't have a table. Well, we would take a point out of the graph, and you can take any point along the line. My advice, though, is to make sure that you're picking a point that is exactly on some of your coordinates, exactly on those axis lines. So I could pick here, I could pick the point 2, 2, 1, 1, 3, 3, right? Probably wouldn't want to pick 0, 0. But any of these other points, what I mean is I would not want to pick a point that was like this, that was kind of random on the line. I can't tell exactly what those two coordinates are. So I'm going to use my pink point, my point of 2, 2. The y is 2. It's up 2, over 2. 2 divided by 2 is 1. So if I wanted to write an equation now for this line, it would just be y equals, I could write 1. I'll write it in this case to not be confusing, 1x. I could also say, right, y equals x, means the same thing. That is this line. And it wouldn't have mattered which point you would have chosen. You would have gotten the same value for k. You would have gotten a value for 1. So each one of these problems is asking you to find the rate of change. So essentially that k, that constant proportionality, and then to write an equation. Sometimes you're given just points. So remembering which comes first, the x and then the y, in order to find the rate of change, you will still use the same formula, k equals y divided by x, and then write your equation. I think that's pretty much it for this one. I'm going to scroll down through to non-proportional relationships. So far all we've been talking about is proportional relationships, so now talking about non-proportional relationships is really the opposite. So FitLife Gym charges customers for each month of membership as shown in the table. Use the information to complete parts A and B. Part A is asking us to sketch a graph to show the relationship between the cost of the gym, Y, and the number of months X. So if you remember, for 0 months, you still have to pay $10. Some people might wonder how that happens, but oftentimes those are things like sign-up fees, right? Just for signing up, you have to pay $10. And then after 1 month, you've spent $30. Oops, I'm putting that at 20. After 1 month, you've spent $30. So that must be the $10 fee in the beginning. Maybe it's $20 a month. After 2 months, you've spent $50. Makes sense. That went up by 20. So even though the rest of these points go in a straight line and they look like it might be proportional, the biggest thing is this line is not, I don't have a ruler, so forgive me. This is not exactly straight. But this line is not going through the origin. If we have a table and we have 0 in our table, we should see 0 and only 0 matching up. If it's not matching 0, 0, it is definitely not proportional. So that's what you can answer here in part B. No, it is not proportional. A relationship is non-proportional if the ratio between the two quantities is not constant. So if we were to divide these points, we would not get the same number, right? If I were to take this point, this 0 months, right? 10 divided by 0 is not the same thing as this point, 30 divided by 1, right? They are not equal. So this would be not constant, right? We're not going to get the same thing every time we try to figure out the K. So non-proportional relationships, like I was just saying, the ratio of y to x is not constant. It does not contain the point 0, 0, but instead when x is 0, y is a non-constant, y is a non-zero constant value. All right, so when we see graphs of non-proportional relationships, the line will not pass through the origin or that point 0, 0 again. Instead, the graph will cross the x-axis as a point known as the y-intercept. So these are still straight lines, right? This is still a straight line on this graph. It's still a linear relationship. It's just not proportional. And what they're saying is this point right here, where this line is crossing the y-axis, is known as the y-intercept. So here you are being asked to make some graphs. Don't skip this question. How can you determine the rate of change in questions 1 and 2? Write down your answer down here, so don't skip that question. We'll talk more about the equations when we get into linear equations a little bit, but see what you can do. See if you can figure out what the equation for this would be. Often equations for non-proportional relationships, they do have some sort of multiplication, but usually then there's also addition or subtraction of another number, that constant. If I were to go back here and write an equation for this, well, 30 divided by 1 is 30, right? So that doesn't really make sense, but I could still write an equation for this because it does follow a pattern. There is a straight line. So I have essentially the number of months multiplied by 20, but then we added that $10 in the beginning. So if I wanted to know for any number of months, 2 months, 2 times 20 is 40, and then plus that 10 is how we would get that 2 months, cost $50. So see what you can do with regards to the equations for some of these. We are finishing up this packet over today and tomorrow, and I'll put more directions in Google Classroom about that.